Last time, we have learned that we can use parametric equations to represent the path of a particle moving in a plane. Now, let's learn the formula for finding the distance traveled by the particle along the path. If a smooth curve C is represented by the parametric equations x equals f of t and y equals g of t over some interval, the arc length can be calculated as follows. How is this formula derived? Let's find out. There are 2 points very close to each other on the curve. In the diagram, the distance appears large, but let's imagine they are very close. Let's name these 2 points pi and pi-1. The distance between these 2 points is defined as L or I. The horizontal and vertical distances are as follows. Let the horizontal distance be delta x and the vertical distance be delta y. Using the Pythagorean theorem, we can find the distance. Here, using the definition of the derivative, we have delta x is about f prime of t times delta t, and delta y is about g prime of t times delta t. The distance can be rewritten as follows. Square the terms inside the square root, and factor delta t out of the square root. We learned that the sum of n rectangles is called a Riemann sum. Thus, we can form a definite integral by summing an infinite number of rectangles. This formula is the arc length formula in parametric form. Let's solve the following example. First, determine the parameter values for the given points. For the point 1 and 1, let's solve for x and y. If x is 1, then t equals plus or minus 1. If y is 1, then t equals 1. For the point 9 and 27, let's solve for x and y. If x is 9, then t equals plus or minus 3. If y is 27, then t equals 3. Therefore, the interval is from 1 to 3. Second, let's set up the definite integral for the arc length, differentiating x with respect to t. The first derivative is 2t. Differentiating y with respect to t, the first derivative is 3t squared. Third, substitute and simplify. Substitute the first derivatives into the arc length formula. Expand. Factor out the squared terms, and simplify as follows. Fourth, use the substitution method to evaluate the definite integral. Let it be 4 plus 9t squared. When t is 1, u equals 13, and when t is 3, u equals 85. Differentiating u with respect to t, we get 18t. Thus, dt equals du divided by 18t, substituting into the definite integral for the arc length, and changing the lower limit and upper limit of integration. Substitute a for the radicand, and substitute dt. We get the following equation. The common factor t cancels out. Simplify, and move the coefficient outside the integral sign. Fifth, solve the definite integral. Using the antiderivative, move the coefficient outside, simplify further, and we get the following result. Therefore, the distance between the given points is approximately 2703. Let's plot the parametric equations. The length of the curve in red between the given x values is approximately 27.3 as we calculated. See you next time.